Hello, everyone. Welcome back to the Rev Games Academy. Today, we're diving into one of the coolest things you can do with physics in Unity, adding force and torque to your game objects. Trust me, this is going to add some real life and energy to your games. So, let's get started. All right, so first, what exactly are force? Think of force as a push or pull that causes an object to move in a specific direction. For example, imagine if you kick the ball, you apply a force to it, and it starts moving forward. In Unity, this is achieved using add force. Next, the torque, on the other hand, is like twisting or spinning an object around an axis. For example, if we spin the ball, it can rotate due to the torque applied. In Unity, you can make objects spin using add torque. So those both are essential for creating realistic physics-based gameplay. Sounds awesome, right? Let's see how it works. Let's set the stage. I've got this little rock object here that I want to push and spin. To start, make sure your game object has a rigid body component. No rigid body, no physics magic. Before we jump to the next step, let's add some personality to our rock by giving it a unique color. Go and right-click the project window and click the Create option and select Material. Boom, a new material is ready to go. Let's name it something like Rock Material to keep things organized. In the inspector, you'll see a color picker. I'll choose a nice brown color because most rocks are like that. Simply drag and drop the material onto your rock object in the scene, or in the inspector under the Mesh Render Components Material property. And there it is. Our rock is now brown and looks way more realistic. Okay, now time to get this rock moving. Unity gives us a magical function called add force. Let me show you how it works. First, I'm going to write a simple script to push this rock forward. First, select your rock object in the hierarchy. This is the object we'll be working on today. Next, go to the inspector panel and click on Add Component. Type in new script and press enter. You'll notice a field appear asking for the name of the script. Let's call it apply force and torque. Easy to remember, right? Hit create and add. Boom. Unity will automatically create and attach this script to your rock object. Isn't that super convenient? And there you have it. The script is now perfectly attached to the rock object. It's time to dive into the code. Simply double click on it and Unity will automatically open the script in Visual Studio Code. Now that we have our script open, you'll notice two default functions, start and update. These are Unity's way of letting us run code at different times. Remove the start function since we don't need it right now. Go ahead and delete the start function. We'll be working with the update function instead. To make our rock move with force, we need to control its rigid body component, so let's set that up. First, declare the variable public rigid body RB. By making it public, the variable will appear in Unity's inspector. This makes it super easy to assign our rock's rigid body from the Unity editor. And save the script and go back to Unity. Select the rock object in the hierarchy. In the inspector, you'll now see a field for RB under your script. Drag and drop the rock's rigid body component into this field. Now our script knows which rigid body it's working with. In the next step, we'll apply some real force and watch the magic happen. Ready? This is the update function. Think of it like Unity's heartbeat. It runs continuously every single frame. This is the perfect spot for checking player input and adding force to our rock. Inside the update method, we write a condition. If the spacebar is pressed, a force will be applied to the rock. So let's write code. If input.getKeyDown, keycode.space, this means it only triggers once when the key is pressed down. Perfect for a single action like adding force. Inside of the if condition, we'll call add force function to move our rock. So let's write rb.addForceVector3.forward and multiply 500, forceMode.impulse. The add force method tells Unity to apply a force to our rock's rigid body. Think of it like giving the rock a big shove. The vector3.forward means we're pushing the rock forward along the z-axis. The 500 is the amount of force. It's like saying how hard we're going to shove it. The bigger the number, the harder the push. ForceMode.impulse. This tells Unity that the force is a quick, one-time burst, perfect for giving the rock an instant boost. It's like kicking a ball rather than gently pushing it. And now if once you press the spacebar, the rock will zoom forward like it's been launched from a cannon. So save your script, head back to Unity, and hit play. And let's see that rock fly. All right, let's hit the spacebar and boom, the rock shoots forward. How cool is that? This is exactly how the add force method works to move the rock object in Unity. But wait, there's more. Unity offers other force mode options you can experiment with. Force mode.force applies a continuous push over time. Force mode.acceleration works like force but ignores the object's mass. Force mode.velocity change gives an instant change in speed without considering mass. Try them out to see how they affect your rock. Change vector 3.forward to vector 3.up and watch your rock jump straight up into the air. Or try reducing the force value for a softer, more controlled push. Play around with these settings to discover how physics can create unique effects in your game. All right, now let's take things up a notch. Instead of applying force, let's spin our rock like a pro using torque. Here's the magic. We'll listen for the T key on the keyboard. When we press it, the rock will start rotating beautifully. In our code, we check if the T key is pressed using input.getKeyDown keycode.t. When it is, we apply torque to the rock using let's write code for rotation RB dot, add torque vector 3.up, multiply 100 force mode dot impulse. Vector 3.up makes the rock spin around its vertical axis. It's like giving it a little twist. The value 100 is the strength of the spin crank it up or tone it down to get the perfect motion. And of course, we're using force mode.impulse, which means we're giving the rock a sudden rotational kick instead of a gradual push. So save your script, head back to Unity, and hit play. And let's see how the rock can spin. All right, let's press the T key and see how our rock spins. Oh no. It doesn't spin continuously like we expected. What's going on here? Well, here's the deal. The spin depends on friction. Our rock is sitting on the plane, and since the plane has a lot of friction, it's stopping the rock from spinning smoothly. That's why it doesn't rotate continuously. But no worries, we've got a fix for this. Remember how we added a physics material to the rock earlier? Let's tweak it. Just go to the physics material and change the friction combined setting from average to minimum. This will reduce the friction and let the rock spin freely. Now hit the T key again, and wow, the rock spins continuously. Isn't that so cool? Physics in Unity really makes everything feel alive. And hey, you can try experimenting with different friction settings to see how they affect the rotation. It's a great way to understand how torque works in the real world. And that's a wrap for today's video. I hope you had fun learning about force and torque in Unity. Now it's your turn. Go ahead and experiment with what we covered and let me know how it goes. If you enjoyed this video, don't forget to hit that like button, share it with your friends, and leave a comment below telling me what you think or if you have any questions. Thanks for watching, and I'll catch you in the next one.